And if you look under the microscope, it will be like low cuboidal to squamous. This is the ovarian cortex, and this is ovarian medulla. Ovarian medulla is loose and ovarian cortex is compact. Now, ovarian cortex contains the ovarian follicles at different stages. Now, the special cell division that is involved in the formation of gametes, and that division is called meiosis. Isn't it called reduction cell division or meiosis? Now, the gametogenesis for women, for female oogenesis, it starts in fetal life, when still in fetal stage. Okay? So when the female baby is born, the ovaries already contain the potential gametes. Gamete formation started in the fetal development in the form of primordial follicles. We will look at primordial follicle, primary follicle, and secondary follicle, a mature secondary follicle. Under the microscope also, you have some very good diagrams in your book. But here we go, the story starts with primordial follicle, the earliest follicle. It develops into primary. This is early primary, late primary, early secondary. When you see that inside the follicle a space appears called antrum, it is filled with follicular fluid, then that follicle is called a secondary follicle. Now this is a mature follicle called Graafian follicle or vesicular follicle, which is ready to rumble down, which is ready to release the female gamete in the form of secondary oocyte, and the process by means of which the ovarian follicle releases the secondary oocyte is called ovulation. So ovulation, due to ovulation, the female gamete is released. I will explain this structure, corona radiata. It's nothing but cells called granulosa cells that surround like a crown around the potential female gamete, which is secondary oocyte. And at the site of ovulation, the secondary is the ruptured follicle. Since the ruptured follicle will have some blood spots, this structure is called corpus hemorrhagicum. Remember, corpus hemorrhagicum, the ruptured follicle. What happens? The cells over here, remaining cells, they divide rapidly, fill in the space, they change their character and form an endocrine structure called corpus luteum. This whole structure is called corpus luteum. Ultimately, the blood clot will be absorbed. Now, corpus luteum mainly secretes progesterone and estrogen, and progesterone is very important for the maintenance of pregnancy. When pregnancy occurs, corpus luteum still in good form, fully formed, doing its function of hormone secretion, and ultimately the function of corpus luteum will be taken over by placenta when placenta forms. But in absence of pregnancy, what will happen? The corpus luteum will undergo degeneration, and this is the degenerating corpus luteum. Doesn't secrete any hormone anymore, and ultimately it will become corpus albicans that will be represented by scar tissue. Okay? Good. So here is the end of the story of the life cycle of ovarian follicle. Okay? Now let us look at this individual. What is a primordial follicle? What is a primary follicle? What is a